In this video, we are going to look at how to analyze a uploaded video of something moving using the Pivot Interactive online tools. So you will see how to upload a video and set the frame rate and the length scale. The tools that are available for analyzing video in Pivot Interactive, how to enter data into a data table from from using the tools and the data tables, and how to make plots in Pivot Interactive using the data that you collect from the video. So the first thing you need to do is open up. So the first thing you need to do is open up a browser window in Pivot Interactive. So, and then we type in Pivot, and I've been there several times, so it automatically fills in. I'll put the link in the description below, and log in. And if I go to my libraries, I already have a tool available for uploading a video. Most of the time there are videos already pre-uploaded, then you can use those. But you may be asked to upload one of your own at some point in time. So to do that, you can scroll down. You'll be presented with this video upload screen, and you can scroll down, choose a file. I happen to have one on my desktop that I believe is the right size. I had to cut it to be less than 50 megabytes, so that's something you want to be aware of. This was taken in slow-mo mode on my phone, so I have to set the frame rate that which you can look up on your phone settings to the frame rate on the phone, and then it happens to be 240 frames per second, and then hit update, and that video will load. And then we have a slow motion video of me walking down the sidewalk. It takes a minute to start up. One of the things to be aware of particularly on the iPhone, but I believe on the Android or other phone systems too, is that when you use slow-mo mode, initially it starts off at full speed, so you want to ignore those first bits. All right, so this is the video we're going to analyze. By setting the frame rate, we've already set the time scale, so I can get a timer on here. But we also have to set a length scale. And I am going to use my height in this particular case, which I happen to know is 168 centimeters. In fact, I'm going to go back to this point here where I'm standing more or less straight up. You might need some posture lessons, but okay. And that is, go from the back of my heel to the top of my head, which is about there. And then I set the scale down here to 168 centimeters. And once I've done that, so that's using this scale setting tool here, but now I can grab a ruler. And so you see this ruler here that we can resize. I'm going to make it smaller. And just to check it, I can also rotate the ruler if I want to. So notice that I set the size in the vertical. And if I rotate that properly, that line there. So starting from my feet, so 0, 50, 100, 150, 160, almost 170 centimeters. So that scale is just right. And this part doesn't matter whether it's a video you uploaded or a video that somebody else has uploaded for you, but you can grab the ruler. Whoops, Okay, so I reset the ruler. And resize it to appropriate and rotate it if you need to. In this case, I'm going to leave it horizontally. And a timer, and I guess you can grab multiple timers, so we can get rid of that timer and use that timer. Okay. And as I said, initially this video is not in slow motion, right? But then it kicks into slow motion, and so I'll scroll ahead till I start walking. And once I start walking, I'm up to a regular pace now. And I'm going to set that 50 centimeter mark right at the brim of my hat. And we're going to use that point to collect data as to my speed. All right. Down here is a data table that we can enter. Again, this is a dummy activity, so I didn't put any details into the discussion, just you normally would see some instructions up here. But we can collect time and distance data. And the time units are going to be in seconds. It's always important to have your units. And the distance data, we're going to put that in centimeters. And I'm going to set time variable to be t, and the time distance to be d, or x. Right? And so we'll collect. So we're going to start at, I've just set my original point to be 50 centimeters. So we'll start that at 1.773 seconds. So at 1.733 seconds. You have to be careful. You have to scroll up and down a little bit. It's a little bit funky that way. And 50 centimeters. And then, so now I can click on the video and I can use my arrow keys to start moving ahead. So I'm going to move ahead until the brim of my hat is at about 70 centimeters. Now, if you want to get a better view, you can also go full screen. And I'm not quite at 70 centimeters. There we go. That's closer. I'm going to escape back out. And this is 1.9792 seconds. 1.9792 seconds. And that's at 70 centimeters. If the video gets that far. Nope, doesn't look like the video is going to get that far. So we'll collect data at 100 and looks like 80 centimeters. Now you have to be careful. Don't move your ruler, because once it's set, if you move it, then if you rotate, you may disturb all the other points, right? So don't grab your ruler while you're doing this. So this is 180. Yes, 80. And this is the time on this is 3.0542. Okay, 3.0542. Yes, great. All right. So I've got a set of data, and now I'm going to plot this. So you go down here to the plotting tool. You click on the scale and choose which data you're going to plot. So I'm going to plot a distance versus time graph. So there's my distance. I can choose an uncertainty column, and I'll talk about that in a few minutes. And then a time, right? And I have a distance versus time graph. And that looks remarkably like a straight line. I am going to see if that's a straight line. So to do that, you can choose Curve Fits. And down here, they give you a number of choices of ways to plot different functions to plot. Linear going through the origin, a regular linear plot that doesn't necessarily go through the origin, which is what I want. You also could choose a quadratic, logarithmic, exponential, a power law, which is equivalent to an exponential, and some inverse functions. If you end up with data that is not necessarily, and that is not one of those, you may have to linearize it, and that's another video. Okay. And it looks like, so I have a straight line plot. The slope, you may remember, the slope of a distance versus time plot is velocity. So if I go down here, I look at the equation that I'm plotting, y equals ax plus b. So a, in this case, is the slope, and the value of a is about 97 centimeters per second, right? Plus or minus a centimeter, plus or minus 2 centimeters per second. So given the data that I have, which is about right, moving at about a meter per second. That's about what I, figure if my stride is a little bit less than a meter, I take a little bit more than 1 step per second. So I move at about a meter per second. Not an unreasonable value. One more thing to consider. First, if we look at these frames, I'm going to go back to, this is a good one. So every frame, so you see between 3.05 and the next frame, which is 3.0542, that means there's 0.042 seconds between each frame. So what that implies is that my uncertainty in time can't be smaller than my frame rate, right? So the distance between frames, in fact, if I go to my calculator here, and I go 240 and invert it, right? I get, this is in scientific notation, so 0.0042, rounding off, seconds is the time between each frame. So my uncertainty in time is that. To enter that into my plot, I can add a column here. I can call it uncertainty. That's in seconds, and I'm going to give it the symbol of dt. And I could put this in as 0.0042 and then have to copy that all the way down for all my data. Or I could change column to a formula. Now this formula could use a whole bunch of, it could use all the data that's in the table, but I'm just going to enter a constant in here, 0.0042, and submit that. More than one cell which contains data. Yes. Okay. Great. And now instead of having to copy and paste it in all 5 cells, if they had more data, it would be more troublesome. It has just put that in. Right. And if I go down here on my time, I can set the uncertainty in time to be the uncertainty in time. And in principle, I should get an error bar on here, right? In practice, the error bar, that error is so small, I can't see it on this scale. However, this is a pretty crude scale for distance. Even blown up, right? The distance markings are 10 centimeters apart. So I would say that I have a hard time telling the distance to within plus or minus at least 1 centimeter, and I'm going to say it's 2 centimeters. So I'm going to put in an uncertainty in distance here, and I'm going to add a column to the right. Uncertainty distance. And that also is going to be in centimeters, and that's going to be dx. And I'm going to change the column to a formula, and I'm going to say that it's 2 centimeters. And then on the plot, I'm going to add the uncertainty in distance to the plot. And now, if you look very carefully, you can see the symbols are still pretty big, but there's a little error bar here. So in fact, I'm gonna be really conservative, and instead of being 2, I'm going to change this to 5. Whoops. So clear 5. There we go. Submit. And now you can see the error bars. And those are very conservative error bars. They're probably overestimating the uncertainty in the distance. But that's roughly what you get. So for each, depending on the time scale between frames and how fine the distance scale is, you may have different uncertainties given your data that you're analyzing. So that is how to use Pivot Interactive. If you have questions, please put them in the comments below, and I will try and answer them. Thank you.